Hello everyone, welcome back to the session. So in today's session, we are going to study expression for the reaction rate in terms of different reactants and products. Now let us consider two different cases. Case 1. Let us consider a reaction in which stoichiometric coefficients of all the reacting species are same. For example, Hg mercury combines with chlorine Cl2 to give HgCl2, which is a solid. Okay. So in this reaction, stoichiometric coefficients of the reactants, that is mercury and chlorine, as well as the product, that is HgCl2, mercury chloride, they are same. You can see here stoichiometric coefficient of the reactant Hg, it is 1, stoichiometric coefficient of chlorine, it is 1, stoichiometric coefficient of the product HgCl2, it is also 1. So this is the reaction where stoichiometric coefficients of the reactants as well as product, it is same. Now let us see how to write the rate expression for this type of reaction. This type means reactions containing same stoichiometric coefficients for both reactants as well as products. Now, stoichiometric coefficients of the reactants and products, they are same. That means rate at which the reactant, that is Hg or Cl2, disappears, at the same rate HgCl2 will appear. Means rate of disappearance rate of what? Rate of disappearance of mercury or Cl2, rate of disappearance of Hg or Cl2, it is equal to what? Rate of appearance of HgCl2. Why it is same? Rate of disappearance, it is equal to rate of appearance. This is because stoichiometric coefficients of reactants and products, it is equal to 1, or it is same. Now in this case, rate of the reaction can be expressed either by taking concentration of the reactant or by taking the concentration of the product also, because rate at which reactant disappears, it is equal to rate at which product will appear. So rate expression can be written like this. That is RAV, average rate, it is equal to, for a reactant we have to write negative sign. In the last class I told you, that is delta concentration of Hg by delta T, it is equal to, again it is minus what? Minus delta concentration of Cl2 by delta T, it is also equal to plus delta concentration of HgCl2 by delta T. Now what is this? Average rate, it is equal to rate of appearance of mercury, rate of disappearance of mercury, it is equal to rate of disappearance of chlorine, it is also equal to rate of appearance of mercury chloride, HgCl2. This is because stoichiometric coefficients of all the reacting species, it is same. So this is the way to write the rate expression in the case of a reaction containing same stoichiometric coefficients. We can take one more example or one more case. I'll take second case. Now what is this second case? In the second case, we are taking a reaction which contains different stoichiometric coefficients. So we have to consider a reaction which contains different stoichiometric coefficients. We'll consider one example. Hydrogen iodide, it dissociates to give hydrogen and iodine. Hydrogen and iodine. While balancing the equation, I have to write 2 here. That is 2Hi dissociates to form what? To form H2 plus I2. Here, stoichiometric coefficients of reactants and products, they are not same or they are not equal. Now Hi, it is the reactant, its stoichiometric coefficient it is equal to 2. H2 it is the product, its stoichiometric coefficient it is 1. I2 it is the product, its stoichiometric coefficient it is also equal to 1 only. Now rate of disappearance of the reactant, that is Hi, it is not equal to rate of appearance of H2 or rate of appearance of I2. No, so we can't equate. Rate of disappearance cannot be equal to what? Cannot be equal to rate of appearance of the product. Now in this case, what you have to do is, we have to divide rate of disappearance of any reactant or rate of appearance of any product by its stoichiometric coefficient, by its respective stoichiometric coefficient. Let us write the rate expression. So average rate it is equal to, since here there is 2, so what I have to do is I have to divide it by 2. So it is minus 1 by 2. It is what? It is minus 1 by 2. So rate of a reaction, that is average rate of the reaction, it is equal to minus 1 by 2 delta concentration of Hi by delta T. Hope you got why I wrote 2 here divided by 2, because stoichiometric coefficient here it is not 1, it is, since it is 2, I have to divide it by 2. If it is 3, I have to divide it by 3. If it is 4, I have to divide it by 4. So here it is 2, so I have to divide it by 2. So it is equal to minus 1 by 2 delta concentration of Hi by delta T, it is equal to plus delta concentration of H2 by what? By delta T, it is also equal to plus delta concentration of I2 by what? By delta T. Now I'll equate these two. Minus 1 by 2 delta concentration of Hi by delta T, it is equal to plus delta concentration of H2 by delta T, or on cross multiplying what I will get, it is minus delta concentration of Hi by delta T, it is equal to 2 into delta concentration of H2 by delta T. By what? By delta T. So we can explain this. See, this is rate of disappearance of hydrogen iodide. Minus means disappearing. So rate of disappearance of hydrogen iodide, it is 2 times the rate of appearance of hydrogen. So hydrogen iodide disappears 2 times. It disappearing at a rate of what? At a rate of 2 while it is compared with what? With the formation of hydrogen. By looking at the equation only we can tell. So here stoichiometric coefficient it is 2. Here stoichiometric coefficient it is 1. So rate of disappearance of hydrogen iodide, it is what? It is 2 times the rate of appearance of hydrogen, or it is 2 times the rate of appearance of what? Appearance of iodine. I will explain it again. See, average rate it is equal to, it is minus 1 by 2 delta concentration of HI by what? By delta T. It is also equal to plus delta concentration of H2 by delta T also equal to plus delta concentration of I2 by delta T. Why it is divided by 2? Because stoichiometric coefficient is 2, so I divided by what? Divided it by 2, so it is minus 1 by 2. I equated these two, that is minus 1 by 2 delta concentration of HI by delta T, it is equal to plus delta concentration of H2 by delta T, or on cross multiplying I will get minus delta concentration of HI by what? By delta T, it is equal to 2 into delta concentration of H2 by delta T. So this is rate of disappearance of HI, this is rate of appearance of hydrogen. Rate of what? Appearance of hydrogen. So what I can say? Rate of disappearance of hydrogen iodide, it is 2 times the rate of appearance of hydrogen. Rate of what? Appearance of hydrogen, or rate of formation of hydrogen. We can take one more example. Nitrogen N2 combines with hydrogen, hydrogen forming ammonia, that is NH3, that is 2 NH3. So nitrogen combines with hydrogen forming what? Forming ammonia. Now how to write the rate expression for this reaction? You can see here stoichiometric coefficient of nitrogen, it is 1, stoichiometric coefficient of hydrogen, it is 3, stoichiometric coefficient of ammonia, it is what? It is 2. It is what? It is 2. Now I will write the rate expression, that is average rate, it is equal to minus delta concentration of nitrogen divided by delta T. No need to divide it because stoichiometric coefficient here it is 1. It is equal to, since here there is a stoichiometric coefficient, since it is 3, what I have to write? It is minus 1 by 3. I have to divide it by 3. So minus 1 by 3 delta concentration of H2 by delta T. By what? By delta T. It is also equal to, it is plus because it is product, so 1 by 2 delta concentration of NH3 by what? By delta T. By what? By delta T. Now I will equate these two, first one and last one, that is minus delta concentration of N2 by delta T, it is equal to plus 1 by 2 delta concentration of NH3 by delta T, or it is on cross multiplying, so it is minus 2 into delta concentration of N2 by delta T, it is equal to plus delta concentration of NH3 by delta T. Now how to explain this? See, this is rate of formation of ammonia and this is rate of disappearance of nitrogen. Now what I can say is rate of formation of ammonia, it is 2 times the rate of disappearance of nitrogen. I will repeat it once again. Rate of formation of ammonia, it is what? It is 2 times the rate of disappearance of nitrogen. Now this is the way to write the rate expression by taking different reactants and different products. Okay, we'll solve some problems. First one, for the reaction, reactant R producing product B, the concentration of the reactant changes from 0.03 molar to 0.02 molar in 25 minutes. Concentration change is given 0.03 molar to 0.02 molar in 25 minutes. Calculate the average rate of the reaction using units of time both in minutes and seconds. So we have to calculate the average rate in terms of minutes and in terms of seconds also. We'll solve it. Say given reactant R producing product P. Now rate expression for this reaction can be written as RAV, that is average rate, it is equal to minus delta concentration of the reactant by what? By delta T. It is equal to, we know that delta R, it is equal to what? It is equal to minus, it is R2 minus R1, R2 minus R1 divided by T2 minus T1, T2 minus T1, T2 minus T1, it is equal to delta T, R2 minus R1, it is equal to delta R. We will substitute the value. It is equal to minus R2, initially it was 0.03 molar, now it is 0.02 molar. So R2 value is 0.02 minus R1 value, R1 means initial value, that is 0.03 by delta T. Delta T value is given, that is 25 minutes. By what? By 25. It is equal to minus 0.02 minus 0.03, that is minus 0.01 divided by what? Divided by 25, or it is plus 0.01 divided by 25, or I can write 1 by 25 into 10 to the power minus 2. 1 by 25 into 10 to the power minus 2. 1 by 25 it is equal to how much? It is 0.04 into 10 to the power minus 2, or it is equal to 4 into 10 to the power minus 4 mole per liter. Time it is in terms of what? In terms of minutes. So it is per minute. So final answer, it is equal to how much? 4 into 10 to the power minus 4 mole per liter per what? Per minute. One more you have to calculate, that is average rate in terms of what? In terms of seconds also. Say this one, average rate value, it is in terms of minutes. I will convert it into seconds. We know that 1 minute it is equal to 60 seconds, right? So 1 minute it is equal to how much? 60 seconds. So here we have one value, that is per minute, means for 1 minute value it is 4 into 10 to the power minus 4. For 1 minute value it is equal to how much? 4 into 10 to the power minus 4, or what I can write, for 60 seconds value it is 4 into 10 to the power minus 4. I want the answer in terms of per second. So what I have to calculate? For 1 second, what is the change in concentration I have to calculate? So for 60 seconds it is 4 into 10 to the power minus 4. For 1 second it is how much? Cross multiply, it is equal to 4 into 10 to the power minus 4 by 60. By what? By 60, or it is 4 by 6 into 10 to the power minus 5. 4 by 6 it is 0.66 into 10 to the power minus 5, or it is 6.66 into 10 to the power minus 6. What is the unit? It is mole per liter per second. Mole per liter per second. So for 1 minute it is 4 into 10 to the power minus 4. 1 minute means 60 seconds. For 60 seconds value it is 4 into 10 to the power minus 4. We have to calculate the value for what? For 1 second. So for 1 second it is how much? That is 4 into 10 to the power minus 4 by 60. It comes out to be 6.66 into 10 to the power minus 6. 10 to the power minus 6, that is mole per liter per second. Mole per liter per second. So in terms of second it is 6.66 into 10 to the power minus 6 mole per liter per second. In terms of minute it is equal to how much? 4 into 10 to the power minus 4 mole per liter per what? Per minute. Next, second problem. In a reaction, 2A giving products, concentration of the reactant decreases from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. Calculate the rate during the reaction. Say given 2A giving what? Giving products. Now we can write the rate expression, that is average rate here. That is average rate, it is equal to, since stoichiometric coefficient, since it is 2, what I would write, it is minus 1 by 2 delta concentration of A by what? By delta T. It is also equal to what? Minus 1 by 2, that is A2 minus A1 by delta T. By what? By delta T. It is equal to minus 1 by 2 A2. A2 means final concentration. It is 0.4 minus initial value. It is 0.5 divided by time required for this change. It is how much? It is equal to 10 minutes. So divided by 10, or it is equal to minus 1 by 2, it is minus 0.1 by 10. So minus of minus it becomes plus. So it is plus 0.1 by 2 into 10, or it is equal to 1 into 10 to the power minus 1 by 20. By what? By 20, or it is 10 to the power minus 2 by 2. 10 to the power minus 2 by 2, or it is equal to 0.5 into 10 to the power minus 2, or it is equal to 5 into 10 to the power minus 3 mole per liter per minute. Mole per liter per minute. So final answer, it is 5 into 10 to the power minus 3 mole per liter per minute. Third problem. For an elementary reaction, elementary means reaction taking place only in one step. Elementary reaction, 2A plus B giving 3C. If the rate of appearance of C at a time t is 1.3 into 10 to the power minus 4 mole per liter per second, calculate the rate of the reaction and also rate of disappearance of A. Rate of what? Disappearance of A. Now what and all values are given? We shall write those values first. Say given 2A plus B giving 3C. Now this is the given equation. 2A reacting with B forming what? Forming 3C. Rate of appearance of C. How to write rate of appearance of C? Appearance means plus. That is delta concentration of C by delta T, this value is given, plus delta concentration of C by delta T, it is equal to 1.3 into 10 to the power minus 4 mole per liter per second. So rate of appearance of C is 1.3 into 10 to the power minus 4 mole per liter per second. We have to calculate rate of the reaction and also rate of disappearance of A. Now first we shall write the rate expression for this reaction, that is RAV, that is average rate, it is equal to minus 1 by 2 delta concentration of A by delta T. So I have to divide it by 2 here. It is equal to minus delta concentration of B by what? By delta T. It is also equal to, since the stoichiometric coefficient is 3, I have to write plus 1 by 3 delta concentration of C by what? By delta T. So rate expression it is like this. Average rate it is equal to minus 1 by 2 delta concentration of A by delta T. It is equal to minus delta concentration of B by delta T. It is equal to plus 1 by 3 delta concentration of C by delta T. First we shall calculate the rate of the reaction. For calculating rate of the reaction, I can take any expression. Since the rate of appearance of C is given, I will take the third expression, that is RAV, that is average rate, it is equal to 1 by 3 delta concentration of C by delta T. Why I took C? Because value of C is given. Formation of C is given. It is 1.3 into 10 to the power minus 4. So average rate it is equal to plus 1 by 3 delta concentration of C by delta T. It is equal to 1 by 3 value of delta C by delta T. It is equal to how much? It is 1.3 into 10 to the power minus 4. 1.3 into 10 to the power minus 4. Let us divide 1.3 by 3. It is equal to 0.4, correct? So 0.43 into 10 to the power minus 4. 0.43 into 10 to the power minus 4, or it is 4.3 into 10 to the power minus 5 mole per liter. Time it is in terms of what? In terms of seconds. So it is per second. 4.3 into 10 to the power minus 5 mole per liter per second. Now this is the rate of the reaction. So value, we got the value for rate of the reaction, that is 4.3 into 10 to the power minus 5 mole per liter per second. One more, we have to calculate what? Rate of disappearance of A. Rate of what? Disappearance of A. This value you have to calculate. I will equate these two, last one and first one. That is minus 1 by 2 delta concentration of A by delta T. It is equal to plus 1 by 3 delta concentration of C by delta T. By what? By delta T. I will take these two to the right hand side, that is minus delta concentration of A by delta T. Now this is rate of disappearance of A. It is equal to 2 by 3. It is what? It is 2 by 3 into delta concentration of C by delta T. By what? By delta C. So rate of disappearance of A it is equal to 2 by 3 into rate of appearance of C. Rate of what? Appearance of C. Or it is equal to 2 by 3 into value of delta C by delta T. We know that is 1.3 into 10 to the power minus 4. 1.3 into 10 to the power minus 4. So it is 1.3 divided by 3. We got the value, that is 0.43. 1 by 3 it is 0.43 into 2, that is 0.43. 86 into 10 to the power minus 4, or it is equal to 8.6 into 10 to the power minus 5 mole per liter per second. So rate of disappearance of A, it is equal to how much? 8.6 into 10 to the power minus 5 mole per liter per second. Thank you.